Welcome, Michael. I'm super excited to have you here. I've been following your tweets for a long time on the Solana community side, but I think people just appreciate your insightful takes and the good times and the bad. I would love to maybe kick off the podcast and just allowing you to do a brief background on kind of how you got into crypto, but then more specifically dive into kind of why you're such a community favorite and what you're building currently.
Oh, thanks, Logan, for having me on. It's an honor, and appreciate the kind words and that someone actually finds my tweets useful. So my name is Michael. Many probably know me as Lane. That's what I go by on Twitter, and that's the name of our validator. So I'm from South Africa, which some might know. And I first got into crypto, obviously, I think like many in the origin story, kind of hearing about Bitcoin back in 2012, 2013, 2014, around then. Bought some for the novelty of it, sold it, unfortunately, never held on to it. Kicking myself ever since. Then around 2017, before the big Bitcoin crash, when we got like 20K or something, I got into Bitcoin mining. Started buying up like ASICs from China and setting them up in a warehouse. And was really kind of enjoying that space of kind of infrastructure around the blockchain and how the actual technology works. Obviously, Bitcoin crashed, wasn't profitable, stopped mining. The miners got corroded and dusted, and that was kind of the end of it for me at that point. Then life happened. So I kind of stepped away from crypto for a few years. My background is in software development. I run a software development company, Web2 company, doing like web development stuff. So been focused on that. And then early 21, or like late 2020, started kind of getting back into crypto, but always kind of kept an eye on the space, but hadn't really been active or investing. Early 21 really got like active again. Obviously mining Bitcoin, the whole ballgame had changed. Never really got into mining Ethereum. And I think for many, the whole reason that they associate with Solana and what they like about Solana is the fact it's fast, it's quick, it's cheap. Those are all the things that, going back many years, I've been thinking or saying that these are qualities cryptocurrencies need to have, and to be able to be usable in everyday life. You can't go to a store, pay for a coffee, and wait 20 minutes for it to confirm. So when I heard about Solana in, I think, February 2021, it immediately resonated with me. And then kind of joining the Solana Discord and seeing how the core team around Solana communicated and their approach to the whole project that convinced me that this is a chain I want to get involved in.
That's awesome.
And that's kind of how I got into Solana, and started a testnet validator in May last year, and then launched on mainnet in August last year. So it's been just over a year now.
Perfect. That's awesome. Yeah, I think going back in time, we all wish we would have got into the crypto space earlier, held on to the coins that we had, and then. But it's very hard through the ups and downs, but awesome to hear that you kind of came back and got more involved again in the community stuff in 2021. And then it's no surprise. I was curious about your background as well, because you're obviously technical on Twitter. And so interesting to kind of hear you had the technical background and even your own company prior. And very cool to kind of hear kind of your thoughts on the Solana ecosystem versus Ethereum. Back in point in time as well, I tried to get all my friends to use Ethereum, but none of them would. It wasn't really until Solana NFTs happened where the gas fees were extremely cheap and the NFTs weren't super pricey that they actually started participating in some of these things and all had a lot of fun. But very cool. Maybe jumping off kind of like your background, I would love to maybe dive into what you're building at Stakewiz and why you wanted to get involved in the Validator community.
Yeah. So I've never been able to really put a finger on, starting at the end of that question with the Validator side. I've never been able to really put a finger on the exact kind of reason that aspect just interests me more. But there's something that is just like, going back in now, very technical in the actual protocol of how Bitcoin works, I thought was just beautiful on a technical level. The way that the literal blockchain is produced and how this, sequence of blocks and hashes just kind of creates this amazing security system, and everything includes everything prior in the subsequent hashes. Like that just I thought was fascinating. And then I think it's just amazing with cryptography, with cryptocurrencies, that you can be involved at this base layer and actually provide the infrastructure and provide for the chain to exist. And there's something about that just really interests me. Same with with Bitcoin mining and now with validating on Solana. And at the same time, it's the first time that I've found a community that I really wanted to be a part of and participate in. Never really got into Ethereum. I'm generally not a big kind of NFT understander. I don't have an issue with it. Other people are into it. I think, I like the idea of NFTs on a technical level. The art side, I don't quite get it. But
gotta love the JPEGs though.
Yeah, I'm excited to when we get to a point in future where we start seeing like event ticketing, flight tickets, title deeds for properties, these types of things moving to NFTs. That's what I would really like to see, and we're not quite there yet. Maybe event tickets to some degree. But yeah, so just like the infrastructure just somehow worked the best for me. And the community has just been great. It's something where I just felt I fit in from the start, and have been able to also provide some value. It's not always easy to find a niche that suits you, that you can add something, and that's really worked quite well.
That's amazing. And maybe kind of get more into what you're building at Stakewiz and the different features that kind of you guys have been working on, because I do think you guys, what you're doing is kind of pushing kind of the Validator community forward on that front. Yeah,
it's not going as fast as I would like.
It never does. We always want it to go faster.
Yeah. The whole Stakewiz project first started September, October last year. But the site wasn't launched until December. And it initially started with the goal of building kind of a more in-depth validator dashboard. So, there are obviously well-known community websites out there that already provide some information, but all of them provided like their own niche of information. So, Solana Beach is famous for its map on the homepage. StakeView was APY. Validators.app had like a bit of a ranking and a bit of technical kind of history on block production and skip rate and stuff like that. So they all had like some of the stuff. And I wanted to build one like really user-friendly kind of site that brings all of that together into one place, but also provides a bit of context to this information. So what are you actually looking at? And that was the initial goal. And then what happened is that towards the end of December last year, a lot of validators, there was this big trend of validators offering 0% commission, which we were also doing. And it's kind of a marketing loss leader type approach. So you offer 0%, it helps you get to the top of the leaderboards, people see you, people stake with you, and hopefully they stick around if in future you raise your commission. So, and that's changed a little bit now, but that was like heavily started towards the second half of last year. And what happened is in December, a few validators changed commission without announcing this in advance. And, it sucks for stakers because they haven't really, it's not part of their social contract with the validator. And I was then able to rapidly pivot what I had been building with Stakewiz already to integrate these commission alerts and delinquency alerts. So you could basically set up an alert for any validator and be informed via email if they change the commission or if they become delinquent for more than a certain amount of time. And delinquency basically meaning being offline, which affects your rewards and reflects poorly on the operations of the validator, depending on how frequent and how long. And that's kind of the first real world use case for Stakewiz that kind of came out. And then we've expanded that by adding other alerting channels. Was some people don't want to put out an email address, so we added Telegram. Now we added Software. We're working on some others in future as well, and just expanded the whole thing with we added the Wiz score, which is kind of a compounded scoring system to try and just distill all that information down into one metric that you can look at, and it gives you an indication of should you stake with this validator, yes or no. So having a low Wiz score doesn't necessarily mean it's a bad validator in terms of operations, because you get a penalty for being in the super minority. So our validator gets a penalty. So our score is quite low. So it's more of an indication of would it benefit the network if you staked with this validator. So it really benefits validators that have a lower amount of stake and these types of things. And we just try to build out from there. Now we've added multi-validator staking, stake management. So kind of building towards just creating a one-stop shop for anything native staking related.
That's awesome. No, I think the community has definitely noticed and is very much appreciative of all the analytics and information that you're providing, all your Twitter threads. No, it's been super helpful. It really is appreciated. I think kind of one of the big things that are misconceptions that I kind of see sometimes in the space is that validators do not make money, or that sometimes maybe start with how validators make money, because you're talking about the commission aspect, and then talk about maybe after that. I'm also kind of curious to hear kind of some of the harder specs today that the Solana nodes are running.
Yeah, so Solana has a surprisingly, I don't know if it's surprising, but it has a complicated financial or economic model as far as validators are concerned. And there's two aspects to it. On the one hand, there's the claim that you need a lot of money to run a profitable Solana validator or to start a Solana validator. And on the other hand is that Solana validators don't make money. So addressing kind of how validators make money, there's basically, my camera's gone really out of focus. Come on. There we go. So validators make money through currently two revenue streams, and there's a third that's emerging. So currently it's commission is the main one. So we all know that average return on staking is around 6% right now on Solana. And that return is paid from inflation. So every epoch, which is 2 or 3 days, new SOL is created and distributed to all stake accounts. And that amount of SOL created averages out to about 6% per annum with compounding. So validator commission is a share of the 6%. Or the 6% is actually net of commission already, but so 6.5 or whatever. So if you stake 100 SOL, you earn 6 SOL per year. The validator takes the commission out of that 6 SOL, 5%, 2%, whatever it is. That's the primary source of income for validators. The secondary source of income is block rewards. So every transaction on Solana pays a transaction fee, even though it's very small. Currently, transaction fees are 5,000 lamports per signature. So it's 1 billion lamports as a SOL, so 5,000 is lots of zeros after the decimal. And a transaction can have up to 10 signatures. So fees between 5 to 50,000 airports. Currently, that's changing, but we'll get to that, I think, later. And what happens with transaction fees is that whichever validator produces the block that includes this transaction gets 50%. The other 50% is burned. So there is a deflationary aspect as well to Solana. Currently, inflation exceeds deflation. In future, it might change. The third revenue stream, just backing up, so block rewards are a much smaller revenue stream. And I would say on average, block rewards are equivalent to about 1% of commission. So if a validator is a 5% commission, they'll basically be earning with block rewards 6%. Yes, it's an easy way to think about it. And block rewards are proportionate to stake. So just as commission goes up and down to stake. The third revenue stream, which is now emerging, is MEV, which is obviously a hot topic, especially amongst kind of, the ARB and the bot communities and DeFi, as well as amongst validators. So we don't really know yet how that's going to play out, how much it's going to be, who's going to capture it, how much is going to go to the stakers. Nice. And then the other aspect, which is how much SOL do you, or how much money do you need to start a validator? The numbers that are often thrown around are that you need 50,000 SOL to break even on a 10% commission, or 5,000 SOL of your own to break even, which is like $1.5 million or something at the moment. So the truth is that's what you need to break even, absolutely. But you don't need to start at break even. Running a validator costs about just under 1 SOL per day in terms of on-chain voting fees. And a validator server will cost you a minimum of $500 a month. So those are your hard costs that you can't get around them. So the reality is that starting a validator, it does mean very likely incurring a loss for a few months. But through stake pools like Marinade, through the Solana Foundation's delegation program, you can obtain third-party stake that will help you get towards break-even. And it absolutely can be done. And we're an example of that. We started with 0 outside stake with 100 SOL of self-stake in August last year. And by the end of October, we were breaking even.
That's awesome. Yeah, I appreciate you walking everybody through that. I think, how validators actually become profitable and make money is often a big misconception. I think another big misconception is, or something that people don't understand, is Solana's kind of inflation rate. It is higher at the moment, but ultimately they're trying to do this just to bootstrap the network. Once the network actually hits like critical mass, and the inflation rate will be higher, the fees will be higher, or because more users are using the network, more fees will ultimately accrue to be able to offset that inflation. So the inflation doesn't have to be as high, which is interesting. But very cool.
So it's actually exactly like Bitcoin.
Yeah.
The Bitcoin inflation is halving every few years, but more and more people use it, and miners get those transaction fees too. So it's the exact same idea.
More people use it, but I agree.
Compared to 5 years ago. Yeah.
Yes, that's true. I definitely appreciate the walkthrough, and awesome to hear that there are avenues for anybody that ultimately wants to get involved in running a Solana node. With any business, I think it's hard to initially bootstrap that, but ultimately, once you kind of gain a little bit of momentum, or the validator node is live, it's been operating correctly for a while, you can achieve more stake and you can help contribute to the community, which I think you are a perfect example of, which is awesome. Maybe kind of going down this rabbit hole a little bit more, I'm super interested. Do you, by chance, have the current Solana specs for like the hardware side?
The rough kind of guide, yeah. So it hasn't changed that much. so at the bare minimum on mainnet, you can get away with 128 gigs of RAM. You'll need, I think you can probably get away with a 12-core CPU as well with 24 threads. The main kind of sticking point with the CPU is that you need to have a base frequency of at least 3 gigahertz or 2.8. So, sorry.
And can you explain why that is?
I was about to. So the Solana has this thing called proof of history, right? Which is like the famous innovation that Anatoly came up with. And what proof of history does is it allows us to process transactions out of sequence and then reorder the transactions without having to rely on a kind of centralized clock. So instead of regular clocks or time, validators use proof of history to keep track of time. And what happens is that essentially the first core of the CPU runs the proof of history hash or algorithm. And that runs at such a high pace that the frequency of the core of the CPU basically represents how many times per second it can do a calculation. And if you don't have at least 3 gigahertz, some say 2.8, but to be safe, just go for 3. If you don't have 3 gigahertz, your CPU can't run this calculation fast enough to keep up with the network. So your core 0, your first core, is basically always pinned at 100%, just trying to keep up with proof of history. And then the rest are like, chill. But that's why it's like this balance, because you get these really high-end server CPUs, like the Epics, that you have like 48 cores or something. But the problem is the more cores you have, the lower frequency you get. So it's about finding that
and
balance.
It's running that same SHA-256 algorithm, the same as Bitcoin on a loop, correct?
I'm not sure if it's SHA-256.
No.
I'm not sure. The Solana private keys are ECD2259, something like that. I'm not sure if proof of history runs on that or on SHA-256.
Yeah, I mean, I think ultimately proof of history is super misunderstood as well. I have a podcast. I think that one will be airing before this one, but Anatoly asked him to explain it in depth because I want people to understand proof of history. It's a very novel concept, but very cool. So those are kind of the minimum requirements to get started. What would you say?
Just to add to that, another very important requirement is you have to have at least 1 gigabit per second network.
Yeah,
up and down.
That was what I was going to ask next. On the bandwidth front, why, in your opinion, is kind of bandwidth needed? A gigabit up and down. Why is that a requirement to run a Solana node?
So it's just the sheer volume of data, and it's if you kind of close your eyes and try and picture what's happening between this network of validators. So please excuse my dog walk around in the background.
That's all good. He's cute.
Yeah, not either. So what's happening with this validator network is that all these validators are coordinating transactions in real time, constantly, through something called gossip, and also through obviously the TPU, which is the regular transaction port. So, and at the same time, validators are able to repair data within their block store that's missing, or where they have received a complete block. Because validators need to replay every block to kind of check that it's valid, that all the transactions are valid, and for them to continue their proof of history. So they can request repair shreds. So, validators communicate in shreds, which is a fraction of a block. And it's just this constant sending and ingestion of data. They're working on ways to try and minimize these things. There's something called erasure codes, which I don't know a lot about, but it's basically a way to ensure redundancy. Yeah. So that if you only get a partial block, you can still recreate the whole block.
Yeah.
And that also takes up a lot of bandwidth. So yeah, that's kind of what leads to it. And sorry, just to add one more thing is that bandwidth usage is also correlated to your stake. So high stake validators use much more bandwidth and continuous bandwidth than no stake validators.
That makes sense. Yeah, I find this as another big, there's a lot of misconceptions in the space now that I think about it, but the hardware requirements for bandwidth, I think it was interesting to me at the point in time where everybody was kind of going in one direction while trying to keep a lot of these hardware requirements, bandwidth requirements small. Anatoly and the Solana team ultimately went the opposite direction. And I find that ultimately people just don't understand that like blocks are data. At the end of the day, that data has to be propagated to at least 2/3 of the nodes, and then voted on and essentially do the execution, and then make sure or the block's valid. And so it's interesting that people have a hard time understanding that like you need a large amounts of bandwidth to actually have like a very high performance chain.
And not just that, so a block is not always a block, right? So a block on Solana is very different to a block on Ethereum. A Solana block is up to 10 megabytes, which is big. And I think Ethereum blocks are about 60 kilobytes or something like that. Something in that range. So, and Solana has a block every 400 milliseconds, 400 to 500 milliseconds. So you're transmitting 20 megabytes per second just in actual raw block data, not including all the kind of metadata around that involved in, ensuring that you have data recovery if you're going to get a partial block, repair requests from nodes that are behind, that kind of stuff. So like with my validators have like 2 to 3 days of data usually. So I've got 2 to 3 days of like every block running in my validator. At any point in time, any other validator or RPC node can request any part of any block in that kind of 2 to 3 day history from me. And that's happening constantly. So in addition to all the actual block processing. So it just, adds to that data volume.
Yeah, for sure. Maybe one thing that I also feel like people have a hard time understanding, especially in the Solana community, is the difference of, say, like an RPC node versus like a validating node. Could you explain the differences and the nuances between the both and what each of those are doing?
Yeah. So essentially, they're exactly the same. An RPC node is a validator in the sense that it runs the same software. It receives all of the shreds of data that comprise a block. They validate every block. They execute every transaction in the block, commit those transactions to their block store, update all the account data. So RPC nodes are fully validating the entire network and maintaining their own accounts store and their accounts balances. The only difference is that RPC nodes don't participate in consensus, meaning they don't hold stake and they don't vote on the validity of blocks. That's the only difference. So, and essentially they're 99% identical.
Nice. Yeah. Because they execute and do all the things that you mentioned, they do count as full nodes, which I think people misunderstand as well. Mm-hmm. So in the Nakamoto kind of coefficient landscape, they're definitely kind of, they are counted correct. They're counted for full nodes for decentralization, not for the Nakamoto.
Well, the Nakamoto coefficient it looks at stake, so RPC nodes are irrelevant to that,
Yeah. But they do help count for full nodes, which is kind of like entangled into like the whole decentralization thing.
Well, what's a little confusing, and using Ethereum as a comparison, is that Ethereum was the first kind of big proof of stake conversation, and the concept of validators on Ethereum. But a validator on Ethereum is something very different from a validator on Solana, because Ethereum validators don't hold the complete state of the blockchain. And in part, that's just because of Ethereum's design. Solana has an accounts model. So what you could think of is that every one of us that has a Solana wallet, at any point in time, every validator and RPC node knows the balance of that wallet without needing to know the history of transactions. Ethereum is kind of a running total. So to know the balance of any wallet, you have to add up all historical transactions and kind of calculate what the ending balance of that is, which means that you need a lot more data. And validators don't hold that data. At the same time, validators on Ethereum, you need 32 ETH to create a validator. But you can't create a validator with 1,000 ETH. So if you have 1,000 ETH, you create 30 validators. So the numbers aren't comparable at all. So yeah, that's I think something that confuses a lot of people. And the comparison is full nodes, and the gap is not that big.
Yeah, I agree. Maybe staying on the topic of like the decentralization, what is kind of your point of views on like broader decentralization, and then kind of thoughts around the Solana ecosystem?
So yeah, decentralization is kind of a difficult question. Everyone has their own definition, I think. There's a camp that says decentralization is running your own node in your basement that holds the whole blockchain history. I fall more on the side of, I think decentralization, and I think it's a range. That is a form of decentralization. Maybe that's the ultimate form of decentralization. But is it the most efficient? No, it's not. And what is sufficient decentralization? And to me, sufficient decentralization is a state where no entity, government entity, private cybersecurity organization, hacking group, whatever it is, can enforce censorship or access control to a blockchain. So, as much as people would like to say that, okay, if I can't run the node with all the data myself, I can't trust this blockchain. The reality is that as long as there's a sufficiently large group of differentiated actors that jointly hold control of the blockchain, and no single one of them can exert control, then you should be able to trust it, because it's just basically impossible for there to be censorship or access control.
Yeah, I definitely lean into the latter camp as well as you. I think ultimately, it is funny, like when you, I've started saying violent facts as like pulling up data and showing people, because I think when you lay it out like just purely from like a data and analytics picture, it paints a much different perspective than people would have thought. And so I'm kind of rolling with violent facts, but it's interesting because, as you mentioned, that first group, a lot of them believe you should be able to run nodes in your home, but don't do that in practice. A lot of the Ethereum nodes are run on cloud providers. And if we're already kind of at that point, I think it truly is then trying to maximize the censorship resistant pieces, which is exactly as you mentioned. So yeah, cool.
So just to add to that, I mean, I'm not saying that it's wrong to want to run your own node. And I think it is desirable to be able to do that, but it's not practical when you're trying to achieve the type of performance that Solana is trying to achieve, and that you practically need to achieve for worldwide adoption.
I fully agree. I mean, technically you could still do it at home. I just don't think very many people would.
I've run a testnet validator on this exact machine that we're talking about right now.
That's awesome.
I actually built it just in order to test if it was possible.
That's awesome. I think a lot of people in the validator, or not validator community, but just more broadly in the blockchain space, are trying to fight physics. There's a certain amount of compute, there's a certain amount of bandwidth, and there's a certain amount of just raw horsepower that you need to actually onboard hundreds of millions of billions of people. And until we get to that point, we're going to stay relatively niche. And so I'm all about the camp that has the best probability of scaling. And if this is what we need to do, then I think we should do it.
Yeah. I think another way of also looking at it is if you try and visualize what is the worst case scenario, the US going nuclear on crypto and just banning all activities related to it, AWS burning down all their data centers. Even if all of those things happened in concert, you wouldn't be able to destroy every replica of the Solana state or the Solana blockchain, and you get in, or Ethereum for that matter. I don't believe that Ethereum is necessarily fundamentally flawed in the sense that it has these weaknesses that Solana doesn't, or anything like that. The truth of the matter is there's basically no way to stop them, and that's what decentralization is. And as long as we have that, then that's good enough.
I fully agree. Maybe kind of moving on from the decentralization topic, Solana, I think, has been rightfully criticized in its past for some of the issues that it's experienced. It's kind of taken, not so much the Facebook model, but they've definitely prioritized growth, which in my opinion, I think is the correct thing. But now as they're starting to scale, focus more on stability. Could you kind of walk us through some of the upcoming proposals that Solana is going to enable to improve performance, but also network stability?
Yeah, so obviously we've had in total 4 chain halts in Solana's mainnet history. First being December 2020, so before basically anyone's memory. I wasn't even around for that. And then September last year and 2 this year. And those situations obviously... Hello, camera. There we go. It goes blurry for you as well, right?
Slightly, but you fix it.
So, September last year, April, and June this year. And it's super frustrating because, you can't do anything. You kind of feel helpless as a user now. And it just makes you question the entire system. But from a kind of more inside view as a validator, what I can say is that obviously it's very frustrating and anxiety-inducing for us too. But at the same time, every validator in these situations has a full copy of the state, or most validators do anyway. So no one's money is at risk. Everything is stored. Essentially, what happens, the network just pauses, and then we just need to figure out how to restart it, which isn't great, but we've succeeded and we've gotten faster every single time. Which people say you shouldn't be proud of being faster to restart, but it also shows that we're getting better at social consensus because. Some people say that one developer stopped the chain to fix a bug, and that's never happened, right? Like, you can't just stop the blockchain. At no times can Solana Labs press a button and stop it. And at the same time, it's not restarted by one developer or group of developers. Every validator has to choose to participate in the restart and choose to participate in the restart settings that have been chosen by the community based on the consensus of what the last state was. But now, in the last few months, we've seen massive improvements in the stability already. And I think that is in part because the core dev team has just kind of stepped a little back from sort of general dev work and focused more heavily on stability improvements. And so the big 3 that kind of are in the works are Quick, obviously. I think most people at this point who are in the space have heard about Quick. The other 2 are fee markets and stake-weighted quality of service. So the first is Quick, which is very close to coming to mainnet. And, it's not like a on-off type situation. So Quick is already active on mainnet, actually. In fact, our validator uses Quick predominantly. We've actually blocked UDP-based packets to our TP port. So we exclusively build blocks of Quick connections or forwarded packets from other validators on the TPU forward port, and vote packets. And that's, been a great test and actually improved the stability of our block building. And so what Quick is basically a network protocol. So some might be familiar with TCP and UDP, which are like the standard bread and butter network protocols. So Quick is kind of, and the main difference is that UDP is connectionless, so you can just send a packet and forget it, and hopefully it arrives. Whereas with TCP, you have to connect, agree that you have a connection, and then you can send the packet. And UDP is a lot faster, a lot more performant, but you have packet loss. So Solana uses UDP, and because of that, it also resends packet, which adds to the bandwidth we spoke about earlier, because a node never knows if a packet has been received, so it'll resend it. And the problem with that is that with UDP, because it's connectionless and there's no acknowledgement of the connection, there's also no way to reliably identify the sender. So someone could spam our validator with transactions, and we wouldn't be able to reliably determine who that person is in terms of their IP address. Because while we can see an IP address, it can be spoofed. So what a malicious actor could do is actually spoof an IP address of another good actor or even another validator to force us to then block that IP and actually cut off a good source or a transaction. So with Quick, what we're doing is we get the benefit of a connection. So you have to have a handshake, and it's actually an encrypted connection, which is even better, while it still has the raw speed of UDP. So what happens is that you go to the validator you want to communicate with, and you say, hey, this is my IP, I want to communicate with you. The validator says, okay, cool. Now the validator, because the validator has had to acknowledge the connection and send something back, knows that that is the true IP and can now control the flow of transactions. So basically, Quick allows us to fine-tune who is sending how much data between validators and to validators. So this means that it gives us more tools in our toolbox that then we can say, okay, this IP is spamming us, we're going to block it for a minute or 2 minutes. And at the same time, we can say, okay, we know the set of IPs that belong to other validators, and we can prioritize data from them. And
No, I think ultimately being able to try to prevent spam, which has been an issue, and preventing denial of service attacks is massive. Combined with keeping that raw speed is super important, and the ability to, by reducing spam, ultimately reducing the amount of bandwidth needed to support that. So I'm excited about that first step. It's much needed.
Yeah, the other step that's kind of related to it is stake-weighted quality of service. So, when you hear quality of service, networking, obviously it's a common term, but other people might not know what it means. But it basically says that you can prioritize some data over other data. And something ISPs do very common. So your network connection, you might find that a Google search is really quick, but YouTube buffering is kind of slow. And that's usually because you have a shaped internet connection. Your ISP is implementing some kind of QoS. So because of Quick, and now we know the true IP of the sender, and we know the IPs of all other validators. So now we can say, okay, we're going to give priority to other validators based on their stake. So if someone holds 1% of the total stake, we will allow them to submit 1% of the total transactions, and no one else can ever drown them out. So you get guaranteed access based on your stake. And it just ensures stability for the network. It's not very different from something we saw last year when we had the September outage. At the time, the spam kind of drowned out the votes. So what happened is the votes weren't able to get through, and the network wasn't able to confirm blocks. So since then, a kind of vote-only safety mode was implemented in the validator. So when the chain advances too far without creating a root block, validators go into this vote-only mode and just prioritize vote transactions to kind of regain consensus. And it's a little similar to that. It just creates this kind of fail-safe environment where you always ensure the kind of progression of the blockchain. Yeah, awesome. And then, fee markets is the other one. And I think this is actually one of the more exciting Quick is very exciting. I think it's a complete rewrite of the network stack of a working blockchain, which is just awesome on an engineering level. But fee markets is very exciting because I think it's really innovative.
I agree.
And if you look at the famous issue with Ethereum and $5,000 transaction fees, it's basically created because of congestion, right? Because the way Ethereum works with gas is that when the network is more congested, you pay a higher fee for block inclusion. And Solana is going to implement something similar, but with a big caveat, which is that the congestion is isolated to the accounts that are congested, which is just great. So what you have is a massive mint that's taking place, and you've got 10,000 people trying to mint an NFT at the same time. All of those mint transactions write to the same Candy Machine account or whatever. So what happens is those transactions are subject to additional fees for congestion. But separately to that, at the exact same moment in time, I want to just transfer 10 USDC to a friend of mine. That transaction is not subject to that additional fee. And I think it's such a clever solution that's really going to not just change things.
I totally agree. I think the innovation of fees per contract versus the global fee market is definitely, the first. And honestly, I've talked with a lot of CTOs now, and they either are implementing it or already have. It seems like this is going to be the standard going forward, and if you don't have this, you're at a severe disadvantage. And I also think it's something that's uniquely enabled by parallel processing. If you're only doing all the transaction execution serially, I'm not sure how you would be able to get this working in your virtual machine. But no, I'm very excited about this. And exactly as you said, that an NFT mint should not be messing up your bid and ask on an order book. And that should not be messing up you sending a couple dollars to and from a friend. So I'm very excited about all these network improvements and what they will ultimately bring to kind of the Solana ecosystem holistically. One thing that I think we haven't touched upon, but is also kind of a misconception or misunderstood as well, is kind of the voting transactions versus non-voting transactions. And I think you've honestly even corrected me on this on Twitter as well. So I would love to kind of get your explanation on like voting transactions, non-voting transaction. Why are there so many vote transactions, and what are like the misconceptions about these two?
Yeah, I think it's something that's caused a lot of kind of anger or confusion, and I don't really understand why. So essentially, the way consensus works on Solana is that validators vote on the validity of a block, straightforward up to that point. The big difference between Solana and other blockchains is that those vote transactions themselves are part of the actual transaction layer of the blockchain. So every vote is itself a transaction. And this has some pros and cons. The one major con is that it creates a kind of a natural base load. And it's not really a con in terms of the technology, but it's obviously created like this marketing issue where some people say that Solana is faking TPS numbers. And I don't think that's fair because they are genuine transactions. These are transactions that interact with an on-chain smart contract program, the Vogue program. They are executed by every validator, and they actually lead to account changes. So they do all the major things that every other transaction does too. Now, the reason that there are so many is that Solana has one block every half a second, more or less. We know that. And validators will essentially vote on every block. So, which means you're voting every half a second. Now we have 2,000 validators. So you've got 2,000 validators voting every half a second, 4,000 votes per second, theoretically. Now, obviously, most of the time we see TPSs between 2,000 and 3,000. So the reason is that validators also club multiple slots together into votes. And Solana as a network is constantly forking just because of the speed at which things are happening. So it's completely natural that you have a fork for a few slots, and then the fork kind of fixes itself, and you're constantly repairing and partitioning and repairing. So in reality, validators vote on about 80% of the blocks that they see, which is how we end up with like 1.5 to 2,000 votes per second. Now, the big question is, if we see a scaling of like 10,000 TPS, do we then have 80% of that still being votes? And the answer to that is no, because votes don't scale with the number of transactions. There's no correlation at all. Votes scale with the number of validators. Every validator votes twice per second, regardless of how many transactions there are.
Yeah, and I honestly think this is the biggest kind of misconception, and I think why today, as the network is bootstrapping with like the actual non-voting transactions per second, while also trying to bootstrap the full nodes, you kind of see some of these wonky numbers. But as Solana continues to scale for their non-voting transactions, the overall number of vote transactions, I mean, I'm not sure what Solana's end goal game is with number of full nodes, because at a certain point you actually get like decreasing performance for the network. Yeah. But I'm curious to kind of see what they end up with.
I think, so currently you would get decreasing performance, but at the same time there's so many performance enhancements that can still be found. Yeah. And we see like some of the work that's happening by third-party dev teams at the moment. Firedancer obviously being built by Jump Crypto, which is a new Solana client. But at the same time, there's been some recent pull requests on the main Solana Git repository, which aren't yet merged into like the main code base, where we can see replay times. So replay is when a validator replays a block that was packed, but that was produced by a different validator. So and that's the kind of key determinator of how long slots take. Right now, they take 500 to 600 milliseconds. There's been an improvement made by the developers from Jito Labs that halves that time, which is a ridiculous amount of performance improvement. So I think that can be addressed. Another thing I just wanted to address with this whole TPS debate, and why it's kind of it's a bad metric. When we look at mempool-based blockchains, Bitcoin, Ethereum, whatever, TPS is relevant because it is the literal maximum that the blockchain can process, because there's a backlog in the mempool of transactions that are waiting to be processed. But Solana is completely different because there is no mempool. So the TPS number we're seeing is not the maximum. What we're seeing is the real-time demand for block space. So it's very possible that we could achieve 10,000 TPS. There just aren't 10,000 transactions waiting to be processed.
This is a great call out. Yeah, the lack of the mempool is, I think, another big innovation. But the fact that ultimately it's based on the current demand, and that validators, even if we kind of hit that ultimate high or achieve like 100% of resources, the software will still be able to scale with additional kind of validators just updating their nodes. Which I find is fascinating, but another big misconception. People are going to watch this and just be like, man, everything that I thought was wrong. It is TPS.
It's just a demand meter. The question is, we don't actually know where the 100% line is.
A lot of misconceptions in this space. And I think ultimately the entire reason why I wanted to start this podcast is to help people, educate people on like these misconceptions, because it's very hard on Twitter to articulate in 280 characters all these nuances that we're going through. But it's much easier to kind of do a long form conversation and break apart all these kind of like complex components. I do want to kind of tease apart some of the things that you did say. There's a lot of things I still want to talk about. You mentioned Firedancer. What are your thoughts on Firedancer? I'm personally very excited as a second independent client, but also the additional performance benefits that they're trying to bring. Could you kind of articulate on a high level what it is and then go into your thoughts?
Yeah, so Firedancer is, an initiative announced by Jump Crypto. So Jump is, a big venture capital fund that's also very active in the blockchain space, runs infrastructure. They run one of the largest validators on Solana as well. And when we talk about a validator client, what it means is that right now, 2,000 validators on Solana, we all run software or code that was written by Solana Labs. Not exclusively, there's over 200 contributors to this code base, it's open source, all of that, but it's still one set of code. It's one client, one implementation, one way of thinking about how to operate the protocol. And ultimately that presents a single point of failure. It's a risk. And at the same time, this would be something that's been built over 3 or 4 years, started out in the very early days, or this is the literal origin of Solana. And a lot of the concepts, the ideas have changed since then. And so we don't know how much legacy junk is in the code base that is slowing things down, and it's going to take time to tease it all out. So it's always better to have other options. And on Ethereum, you have Prism, Geth, or whatever the clients are called. So that we should have the same on Solana. So, and it also creates pressure for Solana Labs or whoever is maintaining the initial Solana implementation, to push things forward. Because if Firedancer comes out and is a million times better, everyone's just going to use that, right? So it's good to have that competition to also just keep pushing everyone forward. So essentially what it is a ground up rewrite of the Solana client implementation, and not just rewriting it in terms of taking what's there and rewriting it, but they're using a different language. They're doing it in C. So they literally have to rethink everything.
And why is it important that it's built in C for people that are not familiar with programming languages?
I mean, I don't know if it's that important that it's C specifically. I think it's great that it's a different language to Rust because it really just signifies how raw this implementation is. C is great because C is just very powerful, very low level. So you can really write high performant code. I do think Rust can do pretty high performance stuff. To be honest, that's a part of software development that is a little beyond me. I'm not that giga-brained to understand all of that stuff. But obviously C is like the holy grail of like low-level programming. And I mean, the team behind it is just highly, highly competent and comes from a high-frequency trading background. So we shouldn't also ignore that they likely have some underlying motivations. They want to obviously be at the forefront of the fastest clients so they can also benefit in their market making and financial activities. But if it benefits all of us, I'm in favor of it because it just creates a environment where Solana is very mature and very stable and just pushes all of us forward.
No, I'm super excited. I think Anatoly said that Turbine initially targeted 1 gigabyte per second, while Firedancer is targeting 10 gigabytes per second, which is super fascinating.
Yeah, I think it's going to be interesting to see how they reconcile. Obviously, they have access to like crazy resources in terms of hardware, networking, and stuff. So it'll be interesting to see how they reconcile using what they have available to the max with what the average validator has. Because it's important to remember that while we could immediately scale to needing like 50 gigabit per second networking, it's going to really drastically reduce the number of validators that realistically can participate.
I maybe kind of pulling a thread on that thread. I'm ultimately kind of the belief that, these validator requirements have to scale, continue to scale, whether it's the amount of CPU cores or RAM or SSDs or more throughput on the bandwidth side. I do think that ultimately it will change things in like who's running validator requirements. I guess like if we did an overnight change where you just had to like 10x all the hardware requirement, that would be tough. But how do you kind of see that playing out? Do you see it playing out more gradual, or do you think it's going to be kind of like a big bang, like, holy shit, there's now this like Fire type of Pokemon Go application. We need a 10x the throughput immediately.
No, I think it'll be more gradual. We kind of saw that massive bang earlier this year with the congestion issues in January, February, which was super frustrating, and then the network halt in April. We saw a lot of validators upgrade from 1 Gbps to 10 Gbps networks because of that. Because that was the core issue at the time, is that like network links were just getting saturated. In April, we were seeing upwards of 50 Gbps in ingress traffic on validators, which is insane.
And that was mostly because of bot spam, though?
Yeah, just bot spam. And so I think we saw like a rush of validators to upgrade. And I feel like the last few months, things have been much more stable and people are kind of experimenting more with the edge of like what can you get by on. And at the same time, we've seen a lot of new server providers that have been kind of entering the space and specifically targeting Solana, and are actually provisioning and offering servers that have the hardware requirements needed for Solana for Solana validators to be able to run, which is great. And I think that just gives us a lot more options because that's one of the hardest issues 2 years ago. Even finding bare metal servers that had the requirements was quite hard. So that's really been an advantage. Long term, like I said, now we've seen this kind of growth from 1 Gbps to 10 Gbps as standard. Not standard, but much more common. And long term, Solana is intended to grow with Moore's law, right? So we're always going to see an increase in requirements. It's really just, and I don't think it's really up to anyone to dictate it. It's going to happen naturally as validators upgrade. The network is always handicapped by kind of the slowest, what we call potatoes.
Slowest 2/3. I'm very curious to see how the validator community continues to grow over time as the network continues to grow. Maybe I don't know what. Maybe touch upon Turbine real quick. Are you familiar with? Obviously,
I mean high level. Not like that. Okay, detail.
Maybe we can skip Turbine. I kind of wrap up some of the podcasts with spicy takes. I saw you had a recently spicy take on your timeline, kind of comparing Solana to Sui. Could you talk about that tweet? What kind of prompted it, and then more broadly, kind of how you're seeing other emerging blockchains today?
I mean, I don't know how spicy it was, but
I think it was spicy.
These new blockchains that are coming out, they all try and find some reason to say that they're the best, that they've got some innovation that's completely unique or different or makes them superior. And I actually don't remember the exact specifics now of that tweet, but I just remember that...
It was the account model.
Oh, yes, right. Yeah, so, we mentioned it earlier in the podcast. Basically, Solana already uses an account model. So it's... and Sui use the object model, I think they called it.
Yep.
So it's... I mean, I think, in that sense, Solana's quite young, but it's also not, right? It's been around since like 2019, 2018. If we look at the origins of the deving, mainnet obviously 2020. So comparing that with something like Aptos or Sui, which are like the two big newcomers now, they're like 3 or 4 years behind. So I think they've got a long way to go. At the same time, it is exciting because it shows us that the future of blockchains is really going into this high-performant, fast-processing method. And it makes you question what kind of future exists for the blockchains that take 16 minutes to finalize a transaction.
Yeah. Violent facts.
Yeah.
I really do think, ultimately, the blockchains, it's really about scale. If these blockchains are not scaling and they still have the unique kind of cool properties that blockchains enable, but do not scale, then they stay relatively niche or relatively only able to be used by people with lots of money. And that's not really what I got too excited about. I got super excited when I kind of envisioned hundreds of millions and billions of people using this. And so I'm very much appreciative of Solana and kind of the next generation blockchains that are focused on performance while still allowing the censorship resistance and all the lovely properties that we enjoy about blockchains.
Yeah, I
cool.
think like this. So just to add one more comment to that, and this won't be so spicy, but I think we do need to appreciate kind of the origins, with Bitcoin and Ethereum, as much as they have design failures, I would say now looking back, in the same way that, we wish we hadn't sold Bitcoin in 2013. The whole idea of blockchain and cryptocurrency started with democratized money and, really censorship resistant, money that you can own fully. And that wouldn't have been possible without the radical kind of concepts of Bitcoin and Ethereum later with the smart contract abilities. But absolutely in future, it's really more about, and I think where we're moving to, and that's what Web3 essentially is democratized internet. It's about so much more than just money. Yeah,
I fully agree. I think ultimately, very appreciative. None of this would have been possible if Bitcoin was not created. And so hats off to Satoshi for creating Bitcoin, and then Vitalik for creating, building upon Bitcoin with enabling smart contracts on Ethereum. When I always kind of talk about these things, I want to make sure people understand that, like, I'm personally very appreciative of all the research, everybody building upon those. I just don't believe that they optimize for the correct things. And that's why we're kind of seeing these next generation blockchains, but it takes none of the merits that they have earned should be taken away from them because of that. There's a lot of things in the space exists and they push the space forward because of that. So good call out. I think ultimately, so kind of talked about like the count model. What is your thoughts on just more other blockchains, maybe outside of like Sui and Aptos? Do you think they're in Solana? Do you think they're optimizing for the correct things, or just more broadly, kind of the rest of the ecosystem?
To be honest, I'm not. I wouldn't call myself an expert on any of the other blockchains. I think Avalanche is one that people would like to probably hear about, but I don't feel like that I'm qualified enough to really comment on the technical aspects of it. Cosmos, I think, is interesting just because of the infrastructure kind of side of what they've built and what you can deploy on it. But ultimately, anything that depends on kind of fragmented layer 2s and, the same with Ethereum and the scaling with the layer 2s, it's just a suboptimal solution. I agree. Like saying the engine in your car is broken, so you're going to strap a horse to it. It's not the right way to fix it.
Yeah, I agree. I totally agree. Well, I think that kind of wraps up all my questions, Michael. I truly appreciate your time. Again, really appreciate what you have done for the Solana community, sharing all of the updates on the node front, what's going on with the network, the uptime, the downtime, the good, the bad, the ugly. We appreciate you, and thank you so much for coming on the podcast.
Well, thanks so much. I really appreciate hearing that. And I hope to just keep it up and see the community grow further.
Awesome. Excited for us to onboard the next 100 million users. We're growing slowly, steadily. Awesome. Thanks again,
Absolutely.
Michael.